when the denominator equals 0. So you have to set x squared plus 2 equal to 0. So vertical asymptotes are when the denominator equals 0. So when you solve this, you get x squared equals -2. And when you take the square root of both sides, you get plus or minus the square root of -2.
Okay.
And this is an unknown value. So this one does have a horizontal asymptote. Do you know where that occurs?
I thought it was none also. But...
It's actually at y equals 0. There's 3 cases. We could cover them all here if you would like. Case number 1 is when the degree of the numerator is less than the degree of the denominator. And that's the case here when you've got 1 over x squared plus 2. The numerator has degree 0 because there's really an x to the 0 here. The denominator has degree 2, and that's from the x squared. So in this case, it's always y equals 0. That's case 1. The second case, case 2, is when the degree of the numerator actually equals the degree of the denominator. Hopefully these things I'm telling you are something you heard in class. I'm just repeating it. So an example of this is like number 2, 9x minus 2 over 3x plus 1. The degree of the numerator is 1 because you have x to the 1.
Mm-hmm.
X to the 1, and the denominator is also 1 because you have an x to the 1. And in this case, it's y equals a over b, and in your problem, it would be 9 over 3. So like it's the number in front of x, or whatever the leading term is. They say the ratio of leading terms. And there is a third case. Case 3 is when the degree of the numerator is actually bigger than the denominator. So an example of this is actually question number 1. X squared minus 1 over x plus 3. The numerator has degree 2 because of the x squared, and the denominator is 1 because it's x. In this case, it has a slant asymptote. And this is when you have to divide.
Oh yeah.
Okay, so I know that was a lot there, but that does summarize all the possibilities for horizontal ones. For verticals, you just set the bottom equal to 0.
Okay.
There's a small variation on that, but probably not worth bringing up for your exam.
Oh.
Okay, so is it your intention that we go through all of this? So it's like starting at 4?
I did 4. Can we go to number 5? I think I did it right. But...
5, both of them, or just one on the left, one on the right?
Yes.
I'm sorry, both or just one?
Oh, both. Yeah.
Okay. All right. So the thing about this one is that what students don't often like interpret correctly is that this 1/4 actually only applies to the 64.
Mm-hmm.
Because this could be written as -1 times 64 to the 1/4, and then you would for sure say, well, it only applies to the 64, and that's how you have to look at this thing. So it's -1 times the 4th root of 64. So here's, and just as an aside here, this is how it would look if it actually was -64 to the 1/4 power. It would have to look like that in parentheses. Okay, so 64 to the 4th power, I don't know what it is, but there's some that you do know, like you know that 2 to the power of 4 maybe is 16, but 3 to the power of 4 is 81. So it's neither of these, obviously, but This one's too big. So the rule here is you break this apart, or you know that 2 to the 6th is 64. Is this one you've remembered?
Yeah, I know
Maybe.
that one, but
Okay, so if you didn't know that, you could break it apart into a factor tree. And you might say, well, why does this help, Matthew? Well, here, the reason it helps is because you're now looking for fours, like 4 groups of 4. So there's 1, 2, 3, 4 there. And for every group of 4, you can bring a number out, bring the 2 out. So I'm going to bring the -1 down times 2, 4th root of whatever's left over, which is 2 times 2. These 2 come over here. So it becomes -1 times 2, 4th root of 4. And you can multiply those together to get -2, 4th root of 4. Is that okay? Is that clear?
yes, it is.
Okay, great. Let's do this other one here. Let me snip it in, but then let me make some like declarations, and we'll do this problem. So this is an odd power. So you can take the odd power of anything. I guess I should say root. You can take the odd root of anything. Of maybe I should say all. Even root of positives is okay. The even root of negatives, that's when you get the I stuff. So because this is a 5th root, like you're good. You're like, oh, I can do that because you can take the odd root of everything. So let's talk about what that means. When it's negative like this, you want to break it apart into 2 pieces. You want to say, oh, this is really the 5th root of -1 times 32, just like we did in the previous problem. And then there's a property that says root A times B equals root A times root B, which means that this is the 5th root of -1 times the 5th root of 32. Reason that's helpful is because this one you can do it just like we did in the previous problem. Sorry about that. Get that dinger off. 2 to the 8, 2 times 8, 2 times 4, 2 times 2. Now there are 5 2's here. That means that this works out perfectly. And in fact, 2 to the 5th is 32.
So it'd be -2 then.
So yeah, this part right here becomes 2. The 5th root of a negative number becomes -1, so it's -2.
For number 6, I did the first and the last one, and I did the middle one, which is like the x over x, but I don't know if I did that one.
Okay, so do you want me just to do the middle one to confirm your answer? Is that right?
Yes, please.
Okay. We can absolutely do that. Okay, you can rewrite the top as x to the 1/3 power because there's a 1 there. The 1 goes up top, the 3 goes on the bottom. The bottom one is x to the 1/2 because there's a 1 there and a 2 there. So if it's not written, it's 2. You kind of got to like know that to be able to do this. And then the property is if you have x to the n over x to the m, this equals x to the n minus m. You have to subtract 1/3 and 1/2. So 1/3 minus 1/2 is 3/6. I'm sorry, 2/6 minus 3/6, -1/6. So when you subtract, whether it's positive or negative, it always goes into the numerator. It's x to the -1/6. So now, while you could write this in the denominator, you want to when you apply this rule, it goes into the numerator as the value. So other variations in the way this could be written. 1 over x to the 1/6. That would be okay. Although I think this top one's fine. You could also go 1 over the 6th root of x. That would also be acceptable as well. So for the last one on the right, the 4th root of y to the -3 power, the final answer on that, one final answer is y to the -3/4, or 1 over y to the 3/4. It's very similar to the one we just did. Oops, slow that back. Okay. Have you attempted the second page?
I started number 7, but I didn't have time to finish it.
Okay.
We'll move to number 8.
Sure. All right, number 8. 3 times x minus 1 to the 1/3 minus 4 equals 2. I call this a direct solve because you could make a substitution for like this right here. You could call that u if you wanted, but you can directly solve for x because there's only one x. There's only one x. Whereas in like 7, x appears in multiple places. So your direct solve here is just a matter of like, are you comfortable undoing and using order of operations to solve? So for example, like you're going to add 4 to both sides. Okay, then you're going to divide by 3. So that's x minus 1 to the 1/3 power equals 2. To undo the cube root, you cube it. So you're going to cube both sides. Now, occasionally you get a problem with a number that's up here that's not 1. We would have to cover that as a side problem, but this becomes x minus 1 equals 8. 2 cubed is 2 times 2 times 2. Add 1 to both sides, and x equals 9. Your instructor actually tells you to check these, and the reason is that you can get extraneous solutions. So the check here, x equals 9. 3 times 9 minus 1, 1/3 power minus 4. Does that equal 2? Question mark. You have to rewrite it exactly the way it was in the original. Like you can't use the manipulated form. 9 minus 1 is 8. 8 to the 1/3 power. That's really the cube root of 8, which is 2. 3 times 2 minus 4 is 6 minus 4, which is 2. These are the same. Okay. Should we move to 9?
Yeah.
All right, number 9. Get my snipping tool, number 9. So I think the best way here is to show you the transformation, show you some things here, and then say why. So I'm just going to perform a step here. Okay, so I factored a 4 out. Okay, to do the transformations, you can't have a number in front of x. You have to have it in this form, and then furthermore, you have to you could, and this is where it's a little bit weird. You can actually take the square root of 4 and the square root of x plus 6 plus 1. And usually your instructors have you do this. So it's y equals 2 squared x plus 6 plus 1. So you have to do all this to actually give it, like, to be able to talk about the up, down, left, right, and then the stretching. Some instructors keep the 4 in here to talk about this. I don't know what yours did, but I think they brought it out because it works out perfectly. So you should expect both numbers to be divisible by whatever's there out in front. Okay, so how about this x plus 6? What do you remember when you had a parabola when it was like x plus 6 squared? Did that move it left or right?
It would move it left.
Yes, this goes left 6, and the order does matter. Although your instructor doesn't emphasize that here. This comes next. This 2. This 2 is a stretch by a factor of 2. Now, it really is a vertical stretch, so I should say that. I'm being somewhat incomplete here by not adding that in. Vertical stretch by a factor of 2. And then the third one here is this 1. And is that up or down when it's positive? Up. So you would say up 1. So do you want one like this?
Sure.
All right, so let's do an example here. Oh, I'm sorry, we're not done. Let me get the example. But so domain and range. It's easier to do the domain and range from this step here, although you could do it from the original. Okay, so you have to set the inside part here for the domain, the inside part greater than or equal to 0. So whatever's inside here greater than or equal to 0. And you'll see if we go back to the original, it's the same way. So here x is greater than or equal to -6. Here it's 4x greater than or equal to -24. Divide both sides by 4. X is greater than or equal to -6. Notice they're the same.
Mm-hmm.
The range, you have to know what the parent function looks like. So the parent function looks like this. Its range, like its domain, actually they're both kind of the same. They go from 0 to infinity. So this one has just moved up 1 in the y direction.
Mm-hmm.
So the range, it goes from 0 to infinity to going up 1 in each value. So it goes from 1 to infinity. So your instructor is just looking for this on the right. Okay, so let me try giving you one here. Y equals square root 9x minus 9 minus 2. Do minus 2 out here. So take a moment, see if you can come up with the 3 transformations on this one.
So it would have a vertical stretch of 3. It would go right 3 and down 2.
Yeah, the order does matter. So I'm going to do it this way. It's right 1 because this ends up being 3 square root x minus 1.
Mm-hmm.
Right 1, vertical stretch by 3, and then down 2. Give me the domain here if you've done it yet or can tell me quickly. It's based on this.
It would be x is greater than or negative or less than or equal to -1.
You have to set this greater than or equal to 0, x minus 1 greater than or equal to 0, and then you solve for x. So you just add that 1 to both sides.
It would be x is greater than or equal to 1.
Exactly. Now this down 2 affects the range. Okay, so the range, like it normally is 0 to infinity.
Mm-hmm.
This down 2 means both of these numbers go down 2. So it's -2 to infinity. Is that okay?
Yes.
Clear enough? All right. Okay, perfect. All right, so next one here, number 10. Number 10 is a graphing problem. Same with 11.
Mhm.
Hopefully you're comfortable. I always tell students, like, just accept that it's going to be on the exam, because then you got a chance, I got to just do it. And the order here of how you do it is important. It'll help. I recommend graphing along the way.
Mhm.
Don't wait till the end to put some stuff down. Does anything pop out to you for either vertical asymptotes or horizontal asymptotes?
The horizontal asymptote is y equals 2.
I agree. So let's put that in here. Y equals 2 right there. So y equals 2. Vertical asymptote is when x plus 2 squared equals 0.
Mhm.
So what value makes that equal to 0?
It would,
What is the only value that when you square, you get 0?
um,
If you said it, I didn't hear you.
I have no idea.
Okay, so let's do it the more literal way here. Let's set x plus 2 squared equal to 0. We're going to undo the square with the square root.
Mhm.
What is the square root of 0?
0.
Subtract 2 from both sides, so x equals -2. So what I was trying to get you to understand is that the square root of 0 equals, I'm sorry, that the square 0 squared is 0. So how do we make this inside part 0, -2? So the vertical asymptote is that x equals -2.
And then she wants us to do the x and y intercepts again. And I kind of
Okay,
struggled on that. I kind of
sure, sure.
spaced out last time.
Yeah, so the let's do the y-intercept first, because it is somewhat simpler. The y-intercept is when x equals 0. So you literally put 0 in for x. Okay, so that's -3 over 0 plus 2 squared plus 2. So you got to simplify this. You got to say, okay, it's -3 over 4 plus 2. What is that? Well, that's, it's 0.75, it's negative, so it's 1.25. So at 0, y is 1.25, and that's about right. Sorry, these things don't, it's a little hard to see, but that's that point there. So we know it probably hits there. So now we got to find the x-intercept. This one's a little bit harder. In some cases, you can just set the numerator equal to 0, but when it's in the form you're in here, you have to set y equal to 0. So it's 0 equals -3 over parentheses x plus 2 squared plus 2, and then you're solving for x. So in one case, you put 0 in for x. In another case, you put 0 in for y. Okay, so we're going to subtract 2 from both sides. So we have -2 equals -3 over x plus 2 squared. And then you can cross multiply here if you write -2 over 1.
Mhm.
So that's -2 x plus 2 squared equals -3. 1 times -3 is -3. Divide both sides by -2. So you have x plus 2 squared equals 3/2. Okay, and then now to undo the square, you have to take the square root of both sides. So square root, but it's plus or minus when you take the square root. So it's x plus 2 equals plus or minus the square root of 3/2. And then you subtract 2 from both sides. So x equals -2 plus or minus the square root of 3/2. You probably have no idea where those points are.
Yeah, no.
And they're not, it's not very helpful. Because we know the graph has the sort of this horizontal and vertical, and we know 3 goes there. The first one for sure does this.
Mhm.
if that's not visible enough, we do it. So that gets one of them. Because at the bottom is squared, that means they're both either above or below they're either both below like this, or they're both above the graph. This is not a good example, by the way, from your instructor. Like, this doesn't help. But that is the nature of this thing. Do you need to do domain and range?
I think we do.
Okay, so let's go back and look at the graph. The graph's kind of the easier one to do this from. The domain, the only restricted x value is where the vertical asymptote is. So it's everything except -2. Are you using interval notation or set builder?
I think it's interval.
Say that one more time.
Interval notation.
Interval. So that's -infinity to -2 union -2 to infinity. Now your range is all the numbers up to 2. So it's all the numbers up to +2, like, because they go down forever, but then this horizontal line kind of restricts it. All right. What else? Okay, is that clear? Could we go on to
Yes.
another one? All right. This one, I believe, is a little bit more straightforward and easier, but this review has them in the opposite order, so it's a little bit, in some ways, it's like, wow, why do this? We don't know. Okay. When you look at this, again, like, do you see horizontal or vertical asymptotes? Like, if you see anything that stands out to you, that's where you got to start, with easier stuff.
So the vertical asymptote will be x = 1.
Okay, agreed. So I'm going to draw that in. And the horizontal?
Y = 3.
Yes, because the degree of the numerator is 1, degree of the denominator is 1. We got it there. So it's y = 3. So that's here. Okay. Now you said we got to find x-intercepts and y-intercepts. Let's do the y-intercept. The y-intercept is when x = 0. 3 times 0 over 0 minus 1. 0 over -1 is 0. So whenever you get the point 0, 0, it's actually both. It's both the x-intercept and the y-intercept. Okay, and like, that doesn't give us enough to graph it, but that's kind of a shorty thing there on that. To do this one, we probably need to pick points to the right of 1 and to the left of 1. So let's pick something like x = 2. So that's 3 times 2. I'm just putting that value back into f of x over 2 minus 1. So that's 6 over 1, which is 6. So we can actually graph that point when x is 2, y is 6. 2, 1, 2, 3, 4, 5, 6. Okay, so there's a point there. That's maybe enough. We don't have to get crazy on this, but we need to pick a value left of 0 I'm sorry, left of 1. We've already picked 0. Just because I kind of looked ahead, x = -2 is a better one for us to choose. So it's 3 times -2 over -2 minus 1. So that's -6 over -3, which is 2. And that gives us a nice ordered pair. If you put -1 in, you'd get a little fraction or decimal there. So -2, 2. And that's enough to graph this thing because we've got 2 points. So that's going to do that. And it's going to do that. What else would you like us to look at today?
This is what we got today. I'll send it over. I think I did them correctly. I just didn't put most of them back in. It should be sending.
All right, checking now. Nothing yet here.
Let me make sure it's sending.
There it is. All right, so a couple images here. Do you want me to check? Do you want us to redo some of these? What's kind of the...
Maybe we could just like review them because it was kind of like a quick thing that we did. And I don't know how many of these are going to be.
All right, so the ones that like an 11 or a 12 would be good for us to look at. Just to, I mean, it looks like you did it right here, but like they're the type that you would see on a test. Yeah, so let me pick 12. We've got lots of time, so I'll just work it through as if it's from the beginning. Okay, so whenever you see two square roots, you're gonna have to square twice. Okay, unless you can get them like both isolated, which you can't here. So that's why this one's, it's kind of, this is the worst case because you got to square both of these. So I'm going to add this term to the other side because we want to keep everything, excuse me, positive. So we have the square root of 3x plus 4 equals the square root of 2x minus 4 plus 2. And then you're going to square both sides. And this is where things get horrible. On the left, not too bad. It's just 3x plus 4. On the right, you have to FOIL this. And if you're comfortable, we can actually just use the a plus b squared formula, which is a squared plus 2ab plus b squared. Are you comfortable with that here, or do you want us to show it as FOIL?
Whichever one you think is easier.
Well, I would rather you know this formula because it'll help you, and it's quite straightforward. You square the first, so that's 2x minus 4. You squeeze these two together, so it's 2 times square. It's 2 times square root 2x minus 4, but then you double it. That's this 2 on the outside, and then you square the last one, which is 4. Is that okay?
Yes.
All right. And it does look like this is slightly different than what you did on your paper. So now this becomes 2x minus 4 plus 4 square root 2x minus 4 plus 4. Okay, just multiplied that in. So this 4 cancels with this 4. That just happened to happen. And then we subtract 2x from both sides. So you get x plus 4 equals 4 times square root of 2x minus 4. So we're isolate the root. Again, I know there's a 4 in front. You would divide if these were both divisible by 4. Okay. Since you can't, we're going to just square both sides again. And that's what I was implying earlier, like you have to square twice. So on the left here, you square the first term, you multiply these together, that's 4x, double it, that's 8x plus 16. equals, you got to square this 16. And then the square undoes the square root, so it's 2x minus 4. So now you distribute in 32x minus 64, x squared plus 8x plus 16. Now you move stuff over. So you subtract 32x, and then you add 64. So you get x squared minus 24x plus 80 equals 0. So now we're looking for two numbers that multiply to 80 but add up to negative 24. That isn't gonna work. Let me check that. Maybe I'm missing one here. 16 and 5, 10 and 8, those don't add up to x squared minus 24x plus 80. Oh, I missed the obvious one. 20 and 4, x minus 4, x minus 20. So x equals 4, x equals 20. And then you have to check both. I noticed in your work that there was a small error in when you moved this original term over to the right hand side. You tried to combine these, but it's 2 plus that, or root of that plus 2.
Oh, okay.
Okay. Now we should check. We should absolutely check these. So let me grab this because they may or may not both work. Okay, so let's try the first one. Square root 3 times 4 plus 4 minus square root of 2 times 4 minus 4. So this is 12 plus 4, that's 16. The square root of 16 minus the square root of 4. So that's 4 minus 2, and that does equal 2. Now let's try 20. Square root of 3 times 20 plus 4 minus square root of 2 times 20 minus 4. So this is the square root of 64 minus the square root of 36. That is 8 minus 6, and that does equal 2. Would you like us to look at 11, which is very similar to this?
Yes.
Okay, I think that's good as well. All right. These are classic examples, but it wasn't on the thing you showed me for your test review. Just point that out, like none of these, but okay. So again, like you want to isolate a root, but there's 2 roots, so you can't isolate the root, but you can move the one that's negative over to the other side of the equation. But again, you cannot combine 1 and square root of x plus 4 because they're different. They're not like terms. Okay. So now you have to square both sides. Square, square. So that's 2x plus 1 equals, and then this is where, again, so if it's a plus b squared, you square the first, then you multiply the 2 together and double, and then you square the last. So squaring the first isn't a big deal. 1 squared is 1. When you multiply these together, the 1 is on the outside, so it's 1 square root. It's 1 square root x plus 4, but then you double it. You double it here. Plus, when you square the last, it becomes x plus 4. 2x plus 1 equals 1 plus, I'm going to multiply that in, 2 square root x plus 4 plus x plus 4. Okay. So again, a little bit more simplifying, it's x plus 5 because the 1 and the 4's go together, plus 2 square root x plus 4. I'm just rewriting here. Now you can subtract x from both sides and subtract 5 from both sides. So that gives you x minus 4 equals 2 square root x plus 4. So we've isolate the root. because we want to square it, because you're going to square these things twice. Like you should be prepared to do a problem just like this where you square it twice. So now we square the left side, we square the right side. The left side is, again, it's FOIL, or that technique I was showing you. It's x squared. You multiply these two numbers together, that's minus 4x, but then you double it. And then you square the last. So it's x squared minus 8x plus 16. On the right here, and this is critical, you have to square both of these. So it's 4x plus 4. We'll distribute that to both, 4x plus 16. So you end up getting x squared, because you're going to subtract 4x from both sides, minus 12x minus 16 minus 16, okay, equals 0. So now you can factor out so x times x minus 12 equals 0. So now either x is 0 or x is 12. But what do we need to do before we can make sure? We got to check, yeah. And boy, you know, it's like, you think, oh, well, these are both nice. Well, maybe they might work. I don't know. Okay, so 2 times 0 plus 1 is the square root of 1 minus square root of 4. So that's 1 minus 2, which is negative 1. That's a problem, because we want 1.
But not negative.
Yeah. So now let's try 1. Square root of, I'm sorry, just try 12. I couldn't see the number. So it's square root of 2 times 12 plus 1 minus square root of 12 plus 4. It's the square root of 25 minus the square root of 16, 5 minus 4, and that's 1, and that's good.
For number 15,
Yes.
that just confuses me because the rest of the stuff that we did was just square root. So like the cube root's kind of
There's two solutions to it. You got 15's perfect, except you didn't get that second solution. Now, when it's remember when I wrote order earlier, when it's an odd root, like it always works. So you don't have to check. You don't have to check when it's even. So you're missing here. It should be equal 0, because when you subtract 7 from both sides, that goes away. When you add 4, so this has to equal 0, comma 3x plus 4 equals 0. X equals minus 4/3. Is that okay?
yes.
All right.
Did I do number 28 correct? I got a really big number for that, so I was a little iffy about it.
Let me look at your work here. U squared plus 9u plus 14, u plus 7. Yep, negative 7. Yeah, they're both correct. There is maybe an issue with, yeah, so there's a small issue with 19. Is it okay if I run through that one?
Yeah.
These are like classic problems they throw on here, and they don't give you an explanation, and then they're like, oh, you should have known that. Okay, so here is the original problem. 2/5 equals 4. And what happens is you get into this pattern of like, oh, I'm just going to undo 2/5, but we forget what this is. This is the 5th root of x squared equals 4. Okay. So how do you undo a fifth root?
You know,
Power 5, right? And you did that over here, but you did something you didn't realize. You actually excluded one of the solutions. So x squared equals, and 4 to the 5th, 4 to the 5th power. Oh, geez, I believe that's 256. Let me check. Losing my mind here. 4 to the 5th is 1024. 1024. Okay. There are two types of numbers that you can square to get a positive number. Because when you square root this, right, you get both plus or minus. So x equals plus or minus the square root of 1024 plus or minus 32. And it all comes from the fact that there's a 2 up there. That's why you have to go down this whole other path.
Okay.
So really quickly, let's try another one here. Let's say you've got x to the 2/3 equals 4. No, sorry. Yes, 4 is good. 4 works. Let's try this one. So the first step here is to write the cube root of x squared. Now, how do you undo a cube root?
We gotta multiply to the power of 3 on both.
Power of 3. So that gives you x squared equals 64. There are two numbers that when you square, you get 64. What are they?
Plus or minus 8.
Plus or minus 8, yeah. So just be on the lookout for that, because I mean it's like a tiny little wrinkle, but it's like there. It might show up on a test. I don't know. That's guidance for here. Is there? We've got enough time for maybe me to look at one more to check if it's correct, or we can stop here. What would you like to do?
Going on with the number 19, would number 2 be correct? Did I do that one okay?
Number 2?
Or not 2, 21.
21. Okay, let me look. 21. 21 is fine because it's got a 1/3 or the 1/3. It's that one is just fine.
Oh, okay.
It's the 2 it gets really dicey.
Oh, there's only even a 2.
They used to give this problem at the University of Arizona graduate program. They would say like x to the 10 equals some number over here, and there's 10 solutions. There's literally 10 solutions. You got to come up with them all, and it's the equivalent of saying like x squared equals a number. There's 2 solutions. So you better come up with all 2 of them. Anything else I can just quickly look at, tell you if it's correct or not?
I think I'm good. I think we've gone through it all.
Looks good. It's nice to see a student like yourself that's working through these problems on your own. Looks like you're doing a great job, and appreciate you scheduling. I'll send you the notes and the screen recording out shortly, and good luck on your exam.
Thank you.
You're welcome. Bye now.